Hello there. Welcome to this video. This is video number 3 in a series of 4 videos where we're going to be writing a password generation script. If you're new to this channel, what we're doing here is trying to learn Linux, specifically the Linux command line, and we are going to accomplish that by writing a series of scripts. Each iteration of the script will get more complicated, introducing new concepts and new commands. Along the way, we're going to write a README file where we're going to store these commands and concepts so that you can go back and reference them later until you feel comfortable with them and don't need to reference any further. I'd like to start out by apologizing for the beginning of the last video. I had some problems, had the screen record set up wrong, and I'm sorry about that. And I know that I'm having a little bit of a choppy breaking up on my microphone. I'm going to do my best to keep it to a minimum, but just try to bear with me as we get through it. So this is going to be the third iteration of our password generation script, and in this iteration we are going to finish with a working, fully functional password generation script. Now in video number 4 we're going to go into some more advanced concepts. It's not really going to be much on the way of changing commands. It's just going to be a conceptual thing where we cover some different bash syntax and ways to do some things in bash that we haven't really talked about, and then some tricks with setting up your script in a way that it can be executed with automatic commands passed to it. But for now, we got to get the script functioning and up and running. And to do that, we should have our terminal pinned to the toolbar at the bottom or side of your screen. So let's pop open our terminal. And as always, I like to go F11 for full screen. And so we're going to start out by editing the README file. And we are going to do a command and a concept to start. Just take that, I'll take all of that right there. One, two, three, four. All right, so this is going to be version number 3 concepts. And we're going to cover change file permissions. And we're going to use the chmod or change mode command. And change mode is the option here that we're going to talk about. And that gets applied to a file. Change mod plus x password gen. That is the command we are going to run. And notes on that would be this command changes file permissions. If I could type permissions, our example makes the script executable for the owner, the group, and the others. And so we're going to go through and work on what actually that means. But let's also put down that the second concept we're going to cover is the bash environmental variable. Environmental variable path. And the reason I'm bringing these two together at the same time is that one plays a role in the other, and I'd like you to see them at the same time. I think it makes it a little easier to understand. Alright, so if we suspend our script for a second and let's just take a look at the change mod command. So first of all, man change mod, you'll see that there's a lot to this, right? There are options, there's mode, there's file. Our primary use, like we discussed, is going to be mode and file. That's what we're going to be doing, is mode and file. But you can see there's some options down here and quite a few other things. We are not going to go into this kind of detail. We're going to just simply use this command to make our script executable. And in order to do that, we do change mod plus X, which means add it executable to it. And what we're essentially doing is telling user group owner or all, right? Those are possible mode options, but you can just shorten all to plus X. So for the owner, the group, and anybody else on the system, it will be executable. And we tell it we're going to change mod on password gen. And now we should just be able to, instead of calling the bash interpreter and then password gen and like help, for example, right? The purpose of this is to make the script executable so we don't have to call the interpreter. So you would think that now that we've made it executable, I should be able to just call password gen, and it doesn't work. So why doesn't it work? Well, that gets to the path variable that I mentioned. So if we echo the variable path, you will see that it contains a list of different directories in which it will look for the file that is trying to be executed. The first time it finds a file with the name of the one that you are attempting to execute in one of these directories, it will execute that version of the file, and you're good to go. Well, the issue for us is you see, if you look at this path does not contain our current path, which is home bashed on my system. On your system, it would be home and whatever your username is, if that's where you've been working on all of this. But in our case, the path is home bash. So if I reference it with home bash, right? Home bash. So it's the full file path to get to the script. You'll see it works. Let's clear the screen. I can also reference it by telling it check the current directory, which is / is the current directory, and password gen, and then -h, and we are good to go. You could also reference it by saying // which is go back one directory, go up one directory, which would be bashed, and then password gen /h. You'll see. So as long as you give it the path, it's good to go and it will execute. Now you can modify on the system the path variable. Generally though, if you're going to make executables and you want them to be executable in the entire system, there's some places that you'll put them, but we're not going to cover that in this video. That'll be covered in version 4. But there is a little bit of a hack we can do for while we are working on something and we don't want to have to put it in a certain directory. And that what we can do is reset the value for path. So take path, and we set it equal to, first of all, the existing path, right? And then we're going to add to that list home /bashed. Now if we echo path, you'll see at the very end there's home /bashed, and if we do password gen -h, it executes. Now that's great and all, but the first time, as soon as you exit this shell session that you are in, that is a volatile variable. It will go away. When you open the next shell session, you'll find that that path has gone back to the default path. So this really just works for while you're in it. We are only going to use it like this today as a shortcut to execute our script. So let's clear the screen. Let's check the syntax though. To check our syntax, we still need the /n. And everything looks good. All right, so let's go back to our README for a second, right? So change mod, you see we did the change mod, the mode we passed was +X, and the file we passed was password gen, and we changed the file permissions. Like I said here, it makes everyone be able to execute the script. Now, the path variable, we're going to take this and copy this into our README. So we cover what we want. Control-Shift-C. Let's go back to our script. Control-Shift-V. And if we were to echo path, what we would get is what's printed there. And this environmental variable is the search path used by the machine, by the OS, when looking to execute a file. Terrible typer, terrible speller. So you see how the path variable plays a role in how we execute things, even though we've given the chmod command to them. So we're going to cover one other concept. So let's blank this out so that we can do that next. Or just prep this. We'll get into the script first, though, before we get into this concept. Need to fix that, apparently. Let's go up here and fix one of my screw-ups real quick. Okay. And this will not be that. Alright. So let's get into, first thing we need to do. Almost forgot, right? We need to make a copy of our current password gen. We're going to copy that to password gen version 2. Okay, now we're ready to now know our password gen. Let's go to the top. First thing we need to do, update the version number. Let's update the date. It's now the 24th. Sorry it's taking so long. Having a hard time getting some of these scripts out, but hey, we're getting it done, and here we are. So what are we going to talk about first? Well, the first thing we're going to do is we're going to add some constants to this list of common script declarations up here, variables, constants, sorry. And what we're going to do is we're going to look at our password length. Let's start there, right? We're going to add a lot of features to the script this time out, but I just want to start by taking a look at password length. Okay, I drove right past it. Look at that. So in our CLI parsing, you'll see that if it's greater than 8 or greater than equal to 8 or less than equal to 24, then we're good. But we're going to change this so that first of all we have a default password, and secondly that instead of defining these in just this location, we're going to define them globally so that we can change them easier, and at the same time, if we need to use it more than once, we'll have a variable for it. Generally, if you're using something more than once, like a set of commands or a variable, something to that effect, then you probably want to set a set of commands and a variable. If you're using a set of commands or a value, you probably want to put those into a function or a variable so that it's easier for you to reference them throughout the script, and when you have to make changes, you have less places that you need to change something. So let's see that in action here. Right, 8 is our current minimum length, right? And 24 is currently our maximum length. Let's go back to the top of the script. Let's do a min length equals, and we're going to do 3. We're going to do a default, a min, and a max. Okay, our default length will be 16 characters, our minimum 8, and let's bump that max up to 32. 1, 2, 3, 4. Okay, now what we need to do is go to our script usage, and over here you can see max length and min length. Now before, if you wanted to change this, you would have had to change it here, you would have had to change it below. This just makes it easier. Let's also note here at the end that the default will now be the default length. And since we are doing a default length, we're going to make the password length an optional argument to be passed at the command line. So let's just go back, check our syntax, everything looks good. and let's run the help message. See what we get. Okay, so you see that we've substituted in our default, our minimum, and our maximum all there in the help message. So that's good usage of those constants. We're going to do some more up there at the top, but for first, let's look at this script usage in this help message. So like I said, in this version, we're going to be adding quite a few options. So the first thing I want to do is, we have a description up there. Well, we've never really used it for anything. So we're going to stick that description right here in our usage. And then let's put some options out there. Probably need to finish that, right? Obviously, the first option that we have, we've already put out there, is password length. Actually, I don't need a blank line there, right? So, and we've already got everything for password length, right? That's where we left off. No big deal. All right. Well, what other kind of options do we want to put in here if we're going to do that? Well, the next thing we want to do is today we're going to look at adding a character set control. And our character set is going to have 4 options. We're going to have an alpha option, okay? And that is going to create a password, actually create an alphabetic only password. And let's cut that a couple times and copy it back in. Our next option would be numeric, mixed, and complex. So here, create a numeric only password. Here we're going to create an alphanumeric password. And here, we are going to create a complex password. So, how do we go about doing such? Well, let's get the rest of our features in here first, and then we'll talk about how we're going to accomplish this. So, echo. What other options are we going to have? We got case sensitivity. And for that one, we're going to have -L for lowercase, right? And this one, create a password where all letters are lowercase. Actually, we should have just cut 1, 2, 3. So what are we going to do? We're also going to have an uppercase one. Pretty straightforward. Even though we're adding a lot to this script, it's really just going to be a lot of copy and paste. And for this one, we're going to use capital M. So we have a mixed case password. Oh, we lost our help message. Oh, there's our help message up there. Got to bring that help message down here. This is our help. And of course, since we made all these changes, we got to go back up here. Let's incorporate these, right? Dash A, dash N, dash M, dash C. Now we've got dash L or dash U. Yeah, get that the right way, right? Or dash M. And there's always dash H for help. So here we indicated what our default was. So our script is going to default to the default length, and a complex password would be the default option, and mixed case would also be our default option. Let's add one more thing here. Let's take the author and creation date and put them in here. So we have written by author created on our creation date. So let's just go ahead and take a look at that help message again. First of all, looks good. Let's take these out and ask for help. What do we get? Well, got a good usage up there. Password gen, optional length, some different options. That looks good. Create a random password. Options are password length and our length, character set. There's our default. Case sensitivity, our default, and help, and then of course the written by and created on. Excellent. All right. So now the question is, how are we going to accomplish this? Well, that starts by the introduction of a new concept, and that is the concept of arrays. So we're going to create some kind of an array and put some values in it. So for that, let's break out. Let's nano our readme real quick, and then we're going to do arrays as the option. Now, an array equals a list of something. An example of that would be an array that contained a list that said dog, cat, food is good. So you see here what we have now is we have a variable, but that variable contains a list. So let's go back to the command line and take a look at this. Okay, so if we take x and we set it equal to dog, and we echo x, we get dog. It's a one-to-one relationship. You have a single value stored in a single variable. Now, x could equal dog, cat, food is good, and when we echo it, we're going to get all of that, but we get it all together as a single element because the value saved in the variable is, like I said, a one-to-one relationship. An array is going to operate differently. So if we have an array, I think I got the whole thing. I didn't get the whole thing. Okay. Let's take array equal to dog, cat, food is good. So what we have here is we have a variable, but the type of variable we're working with is an array. And inside the array, instead of a one-to-one relationship, it's an n-to-one relationship. You have an array and it has an n number of elements. Now, the way we have it defined now is the basic way you can define an array in Bash, and if we hit enter, it is now defined. So what does this do for us? Well, we want to start out by echoing it, right? So we echo array. What do we get? We get dog. Well, what has happened here is we haven't called the array as an array. We've called it as a variable. And so Bash has just dropped it down to that one-to-one relationship and given you the first element. The correct way to call arrays are to call it, you have to call it inside of a curly bracket, and then you also need to give it something inside these square brackets to get a location. What do you want from the array? Which indexes do you want to pull from the array? So if we put the @ sign here, we are going to get everything. Now, that doesn't seem that impressive because it's exactly the same thing we did with the dog, cat, and food is good when we stored it in X. But that's because we're using echo. Okay, let's see what happens if we did printf, and we told printf to print a string and a new line, and it's going to do that for whatever it gets out of here. And we need to double quote this. We should double quote our variables when possible, and it's important in this instance. And what do we get? Now we get 3 items broken up separately, right? We've referenced the array and all the values inside of it, but the array values come out, and what happens is what you see here expands to, instead of array, it expands to dog as one thing, cat as another, and food is good as the last. What happens if we don't quote it? Well, when you don't quote it, as you see there, if printf sees them all as single elements. So instead, what you got was this, right? That's exactly the same thing they printed out. So the real power in the array, though, is that we can tell it, give us one of your elements. So what elements do they have? Well, this is a simple indexed array, which means it's based on numbers, and it's biased at 0. So the first element in the array is 0. So if I tell it to print element number 0, I should get the word dog. And I do. If I go to 1, I get cat. I go to 2, I get food is good. Now you see that it's not quoted, so it broke that down into 3 separate items. So we really got to quote that. There we go. Food is good. And if we want all the items in the array, we can do the @ sign. Now there is also the option to do the star sign. And as you see there, the star sign destroys our configuration of the array as multiple elements, disregards white space, and essentially just prints them all out as a single element. And if you take them out of the quotes, we're going to get each of those printed out by themselves. But really, for what we're doing and what we're trying to cover in this concept is we want to cover the concept of either printing a single element or normally printing the entire contents of the array. Of course, that's not quoted, so not really a good example. Let's do that again. Entire contents, okay? So where does that play in with what we're doing? Well, first of all, an array is a variable type that stores values in an n-to-1 relationship as opposed to a normal variable which stores values in a 1-to-1 relationship. So an array is like a list. If you look at Python, they have lists and they have dictionaries. But at the end of the day, an array is just a variable that can store multiple values, and you can reference them in multiple ways, as opposed to just a regular variable where it's a stored value, and that's the end of it. Now, there are some other things that we could do with our array, and we're just going to cover this really quick. I'm not going to get into too much depth. Come on. Array. Where is it in the search? There we go. Okay. So this is element 0. Well, we could have declared this element 0. We could have declared this one element 1, and we could, just for fun, have declared this one element 37. Does our printf work the same? Yes, it does. Until we get to 1. There's 0, there's 1. What about 2? That's empty because we skipped that, and bash allows for empty indexes in the array. So we can actually just jump right ahead to 37, and there you go. Now, the other way you can declare an array, and this is outside the scope of what we're going to do, but you can declare, you have to use this declare command and the capital A on an array. And then we could do me equals dog, her equals cat. And I didn't close. There we go. And now, if we print f, you see that the 2, the 1 doesn't do anything, but you can reference the me or the her. Since that requires the use of the declare command, which I'm going to cover declare in the 4th video, we consider that outside of the scope of this, but you can declare arrays in different ways. For us, we don't need to do anything special. When we declare an array, we're just going to give it a name. We're going to set it equal to something, some kind of values, and we're good to go. Okay? So let's go back to our script. So what kind of arrays are we going to define here? Well, what we're going to do is we're going to create an alpha characters array. And then, of course, we're going to need a numeric characters array. And we're going to do an alpha numeric. We'll call it alnum. And then the last one we're going to do would be our complex array. All right, so how do we populate these? Well, we want to get A through Z here. We want to get 0 through 9 here. And then we want to mix those things up for the last two. So what we're going to do is, to make this a little bit faster, and I'm not going to cover this in the README, but we're going to just take a little command line shortcut here. And what we're going to do is we're going to do this quick for loop. We're going to use bash's built-in listing feature. So you see this curly bracket combination here as part of the for loop. This is a list, a range. Okay, you put your starting point of your range, in this case A, and your finishing point of the range, in this case Z, and then each time through the loop, it is going to populate that A.Z as all the letters in that range as it's shown. So for each time through the loop, it's going to be letter will equal A, then letter equal B, until it works all the way through till Z. And then you see here where you're doing a printf on it, forcing some double quotes into it, and you'll see why in a second. And we're printing the letter, we're done, no new line, and then after the loop completes, we're echoing, and that's just to get us a new line. So what do we get from this? Well, we get A through Z, and they're all double quoted, which is perfect, because we can just go copy this, Control-Shift-C, get back to our alpha characters, Control-Shift-V. Wow, just like that, we've got all of our letters. We can do the same thing with numbers, and we'll go ahead and copy those. And there's that array. And I just want to go back. I'll touch on one more thing with this loop. You can make these numbers anything you want. But you can also increment this list. If you add another 2 dots, you can tell it, print out the values in this range, but increment them by, let's say, 5. And you see we get 10, 15, 20, 25. If we were to change this number to 10, we can increment 10, 20, 30, 40, 50. And then if we increment by 90, we just get 10 and 100, right? So it's a nice little for loop trick. It's just something we're not going to put that in our README. It's not really used in the script, but it is handy to know. And we may use that in something else that we do in the future, but for now, that's a little shortcut to help us out. So now, how do we define these two arrays? Well, we can just call our existing alpha characters, right? And then to call all of them is the @ sign. And additionally, we can call our numeric characters, maybe. And now we have alphanumeric. And of course, for this one, we can call our alnum characters. And then we need to add some special characters. Missed one there. And then okay, so we got a bunch of special characters, right? Complex in our array. 1, 2, 3, 4. Okay. So now we've got our arrays defined, and what is this going to do for us? Well, the first thing this does for us is it's going to replace this case statement, right? Because now we have someplace else to store all these letters. Now see before how we had that one-to-one relationship with a variable to a letter, and then we had to use this long syntax in order to extract or define the correct letter the way we want it. But not anymore. So we've got all those arrays up there and some default definitions. So let's first start, before we get into the body of the script, let's look at our CLI arguments next, right? So we are going to have a change in the function, but we'll come back to that one. And let's just look at what we have going on here, right? So we still have the L option, but we have to add in here our alpha, numeric, mixed, and complex options, as well as our lowercase, uppercase, mixed case options. Okay? And what we're going to do, we're going to start out down here by looking at our character set, because that can be passed from the command line. And sensitivity, case sensitivity. And so the character set started with what? Well, it started with our alpha, right? Now, what we want to do is we need to assign whatever the chosen character set is to some sort of an array so that we can reference it later. So what we're going to do is we're going to use a new array called the character set. It's going to equal something. So what do we do with that character set? Well, when someone selects a character set, first thing we need to do is make sure that someone hasn't already selected a different character set. Right? So let's see if we want to make sure that this array is empty. So the -z option is, does the value that we are expanding have a 0 length, or is it empty? In the case that it is, well, that's good news. That's what we want. We're going to take our character set and we're going to set it equal to our alpha. Characters. I missed. Man, struggling today. Not good. Okay. What happens if they've already set something, though? Well, in that case, we need to echo cannot use more than one character set. And of course it's an error, so we want to spit that out and redirect it to 2, our standard error. And then what we want to do to get out of this is show the script usage so they know what they're supposed to do, and put that 1 there to go with it, so it ends, the exit code is error and it's 1. Now we need to do this for the rest of the character sets, but luckily this is, oh wait a minute, we got to close this case statement though. This is going to be a problem. All right, now we're good. So we take this whole thing, alpha, numeric, mixed, complex. All right. So there's our character set: alpha, numeric, mixed, complex. Alpha's good. Let's go here. We would want to just change this one to numeric. Mixed is alnum. And this would be the complex. Good. All right. Well, that handles character sets. So what about case sensitivity? Well, it's pretty much the same idea. So let's copy another one of these. Go down here. Put this in. So what do we want to do here? Well, we need a lowercase option, right? What are we going to check for here? Because we're going to follow the same idea. Well, we're going to introduce a variable, and that's going to be set case. And set case is simply going to tell us what case sensitivity has been set, right? So for our lowercase, we want to start out by making sure that set case is still empty. And if it is, we want to set case. We want to set case, right, to lower. If it's already set, you can't use more than one case sensitivity. Same exit idea, same, everything else is pretty much the same. So we have 3 of these. So if we copy this entire thing, there's 3 of them, right? We've got lower, upper, and mixed. And we just need to change these. That's upper. And mixed. So now we should have all the options we need. Now, since password length is no longer required, we can remove this from the script. And let's go down here and look at these 2. And there's actually going to be a 3rd variable that we are going to need to add to this. And that's going to be the character range. So the character range, we actually were doing this before. We did have a character range for it, we just weren't using a variable for it, right? And that was the range of numbers that covers whatever characters we have defined. So here, 1 through 36 was our character range, right? With 36 being the top of the range. If we go back to get numbers, you'll see The input range is that same 1 through 36. So we've got to change this. And the first thing we need to do is we need to change it because we're using an array. Arrays are 0 biased, so we want to start with, hey, you can use a 0. And then how far do we want to go? We want to go as far as the character range will allow. So the question then becomes, how do we figure out what the character range is? The character range is just a matter of taking the character set and all values in it and measuring the length with the pound sign. So this is a bash parameter expansion we haven't covered, but we will go over very quickly. X equals dog, and if you echo X, you will get dog. However, bash also has the built-in ability when you reference it, the parameter expansion can instead just tell you how many letters or numbers, how big, how long the value stored in the variable is. And you'll see in our case it is 3. If we change dog to tacos, you'll see our length changes to 5. So we do the same thing with our character set. We just expand it, and then that pound sign is a parameter expansion that measures the size of the character set. So that's pretty good. Okay, we got that covered. Now, what about this set case and the character set? Well, these are all options. They're no longer required at the command line. So instead, what we need to do is build in a manner in which you can get the default values out of them. So what do we need to do? Character set. Well, character set is going to equal either character set, right, or we can use that parameter expansion we learned the last time, where if it doesn't have any kind of value already stored in it, then we can reference something else. And in this case, the default would be to reference the complex characters array. So what's happening here is when we get to this section, character set will either be redefined as the character set that was already set above, or if nothing was set, it'll be defined as this complex characters. And you got to watch this because of the extra square brackets and curly brackets. When you do this, you just have to be careful. First of all, this has got to be inside of the curly bracket for the array, and then the new item you sit inside of the array has to have its own proper syntax. So set case is going to follow the same idea. It's either going to be equal to set case, or if it doesn't have anything, then mixed is our default case. So that's good. Well, what about our password length? And that, again, same idea. It's either going to equal the length we set above or our default length. Got to get that pound sign out of there, right? And let's just make a note. Set these two defaults if not already set. Not already set. All right, so far so good. So we've got all of our definitions. I'm going to make one other change. Down here in our for loop, we're going x equals 1. I want to declare that up here. I'm going to set that x equals 0 though, which we need to do the same thing down here. But an important concept here, let me put that 1 back in and cover something. the syntax you see there, where x equals 1, x is less than or equal to password length x plus plus, or x equals 0, x is less than password length x plus plus, the syntax accomplishes the same thing. If password length is 10 and we start at 1 and we go until x equals 10, we will get all 10 iterations. If x is 10 and we start at 0, we will get 0 through 9, which is 10 numbers, so we get all 10 iterations. But normally you would start at 0, and so we're going to change that so that it matches up with what we would normally do in another script. Alright, so do we have everything we need? No, we don't though. There's one change that I forgot about that we need to make, and that's for this. Since the array is 0 biased, what on earth? The length needs to be -1. So what does that mean? Well, first of all, that means we need to do some math, and as we've covered before, $, double parentheses means everything inside of it is math. We've got a number there. Let's subtract 1 from it and save it. So why do we need to do that? Well, if the array has the 3 elements we talked about before, dog, cat, and food, by default those values are going to be stored at 0, 1, 2, which is 3 elements. So our character range would be 3. But the problem is if we put 3 in the character range and then we try to call index number 3 in the array, there is no index number 3. It's 3 elements long, but those 3 elements are 0, 1, 2. And because it's 0 biased, we're going to take the character set value, the length of the character set, and we're going to subtract 1 from it to get us our working character range so that we get 0 through the maximum number that's stored in that character set array. So now that we have that, let's just take that line out. Okay, that's all of our definitions. Let's go down here to the body of our script, and let's take all this out. We're still going to use that random number though. In this case, what we're going to do is take new letter, and we're going to make it equal to our character set where we get the value of a random number. So see, this is how a random number gets generated, and then we extract that point, that index in the array, and set it for our new letter. So this is doing exactly what the case statement did, right? We got a random number and it picked a value that had a letter or number stored with that value to be the next new letter. But in our case, we're using this flexible character set because the character set can be redefined every time the script is called, and it allows us to have defaults and flexibility. And in this case, we're using the random number we've generated to pull it out of the character set we've defined and apply that to new letter. Then we go down and we do our normal routine, same thing we did before. We use get number to extract another number that we then determine if it's odd or even to see if the value currently stored in a new letter needs to be forced to uppercase or left at lowercase. Now I know that there's some lowercase and uppercase options that we pass at the command line, and this kind of goes against this. Well, what we're doing is we're just going to do this so that we get the mixed, which is default. However, if the user does pass one of those lower or uppercase case sensitivity commands, then we're going to build one extra step in here for them, right? And that's, we're going to handle case sensitivity if required, and we're going to do nothing on mixed. So we're not even going to put an element, any definition in for mix. So what do we want to do? We're going to case, and we're going to look at our set case command. Double quotes, got to be double quotes, $sign set case in. And what were our choices? Lower. In that case, we would take the entire output password, set it equal to the entire output password, I'm screwing it up left and right, aren't I? And to go lowercase, it's like we talked about before, 2 commas, there we go. So now we've handled forcing everything to lowercase. So see what happens is we generate a mixed password, but then if the user has specified a case that they want it to be it upper or lower, we're now just quickly checking that, and if we need to, as we do parameter expansion, we either force it to uppercase or force it to lowercase. So it should appear pretty much the same kind of syntax, should be straightforward, and hopefully at this point you understand what we're doing and see that this is actually rather easy. So it's the same idea. If they've selected upper, we're just going to parameter expand output password, forcing it to upper when we expand it, taking that expanded value and applying it to our output password, which then in a few steps gets printed out. And just like that, we should have everything we need. So let's take a look. First of all, can we parse the command line options? We can parse the length of the password. We can parse alphanumeric, mixed, complex, lowercase, uppercase, mixed, and we have length, alpha, numeric, mixed, complex, lower, upper, mixed, and our usages. Let's check our script usage. Looks pretty good. Let's go ahead and clear the screen, check for syntax errors, because we kind of drove right through that one pretty quickly. No syntax errors, that's a good sign. So let's start out with just checking our help message. We've got a pretty extensive one now, but you see we have a lot of options that we built in, and in this case we built them in very, very quickly. So I'm going to, let's just, while we have that help up, I'm going to run it with no options whatsoever. So we should get defaults, right? The default length should be 16. It should be a complex password, and it should be mixed case. And that is exactly what we got. So we could force it all to lowercase, and you see that that works, or force it all to uppercase. That's good. What about mixed case? Oh, looks like we have an error in our script. Let's check that out. Ooh, we broke the password length when we did that. We moved that colon out. Yeah, any day now I can type a colon for you. Okay. How about mixed case? Hey, there we go. That's better. Okay. So we did, let's do alpha only, numeric only. And it's important to work through these options. We had mixed, we had complex, alpha with lower, alpha with upper. Let's mess with the password length here. 32. You see that was all upper letters. Let's do all lower letters. Make that numeric. Obviously the uppercase, lowercase doesn't work. Take that out. Let's try something too big. Get our error message. That's perfect. Invalid value for length, 34. As you can see, it can only be 32. All right, so let's change that to 21 and mixed. And I think we've covered all of it. And by default, we should get complex 16-character password. So we've gotten a pretty good sized script here. At this point, this script is fully functional for generating a password. You can use this script, call it in a number of different ways. It has a help message to help you figure out the syntax, and then you can get yourself a random password quickly. And there are other applications out there that do this, but the point is to see this script in action, use the different features, and help you understand how bash works, because if you can understand how this bash script works, then you'll be able to operate the command line just as well, right? So we covered setting arrays in the script. We've covered for loops, right? X equals 0, X is less than 5, X plus plus, do, printf, %s/n, ARR, and if that value is empty, let's stick empty in there. Invalid character format. I'm missing the %s. There we go. Cat, dog, empty, empty. And it doesn't seem very useful now, but if we were to list our current directory and set that AR up into, say, equals password gen and readme bashed for file in our array, let's do something different. Let's have it ls-l, which is just long listing of the file, but we'll give our properties as well. The word file. So if you see what we did there, right? We can take some kind of data from the file system, we can store it in an array, we can loop through the array. So I just want to show that these commands that we have used in this script, they apply to the terminal, because the terminal is just a bash shell, just like the script is just a bash shell. So if you can master the commands we put in the script, then you can master the shell, and before you know it, you'll have the Linux command line completely down. So that's going to be it for today. At this point, we have a fully functioning password generation script. Version 4 is going to introduce some advanced features and concepts. Now, these won't change the way the script works, but rather demonstrate some bash concepts and script execution ideas that are less common, but valuable nonetheless. If you've enjoyed this video, be sure to like, subscribe, and hit the notification button to be notified when new videos come out. And thank you.